Hi everyone, this is example 1 from chapter 13 in your student packet. It says, assume that 30% of students at a university wear contacts, and that we randomly pick 100 students to see what percentage of them wear contacts. Describe the sampling distribution. What is the probability that more than 1/3 of them wear contacts? So first I want to talk about the assumptions that need to be met in order to talk about this sampling distribution. So we saw in the previous video using the applet that a sampling distribution for proportions when we take many samples follows a normal curve. But there has to be some assumptions and conditions that are met from our samples in order to guarantee that this happens. So the first is that, I'm just going to write the conditions and assumptions. So the first is that these samples are random. So in this problem, it says that we randomly pick 100 students. So we've met that condition. The second condition is called the 10% condition, or at least that's what we're calling it in our text. And it means that our sample size cannot be so large that it's more than 10% of the population. So sample size cannot be more than 10% of the population size. Well, we're choosing 100 students at a university with the idea that the population of students wearing contacts would be hundreds of thousands. So, or just not even students wearing contacts, just students would be hundreds of thousands. So this condition is met. We can say 100 is less than 10% of the population of students. So we want these two conditions to be met so that we can assume that the individuals within our samples are independent. We don't want any groups of people in our samples to have a relationship. So as long as we make sure that our samples are random and that our sample size is not so big that we can't guarantee this, so by meeting conditions 1 and 2, we can then say that the individuals within the sample are independent. So again, we can say that this is met when the first two are met. And then lastly, we still need to make sure that our sample size is big enough. And for proportions, big enough means that we have at least 10 successes and 10 failures, which means that for this sample size, we would have at least 10 students that are wearing contacts and at least 10 students who don't wear contacts. So this is called the success-failure condition. And this is specific to proportions. So to figure out our number of successes, we take and multiply the probability of success times our sample size, or n times p, which in this case is 100 times 30%, or 0.3. And so our number of successes would be 30. And then the number of failures you can find one of two ways. So we can either take n times q, so the sample size times the probability that we don't wear contacts, or you know that the number of successes and the number of failures are will make up the entire sample size. So you could take 100 minus 30. I'll stick with the NQ, so I'm going to take 100 times the complement of P, and we will get 70. So all of these conditions and assumptions have been met. Now I actually want to get to the problem where it says describe the sampling distribution. So again, from that applet, we know that the sampling distribution is going to be a normal distribution. So we use a capital N to denote that this is a normal distribution. And then with this normal distribution, we want to write the mean and the standard deviation. So for this problem, we know that the mean of the sampling distribution is going to be the same as the population proportion. So the population proportion is 30%. So we know that the mean of our sampling distribution is going to be 30% or 0.3. The standard deviation is given by that formula of PQ over N. So in this case, the P is 0.3. Q is the complement of P, or 1 minus 0.3, which is 0.7, over the sample size, and our sample size here is 100. So if we calculate this, we'll have a mean of 0.3 and a standard deviation of 0.0458. And then finally, the question says, what is the probability that more than 1/3 of our, so it's asking what's the probability that our sample proportion is more than 1/3. And 1/3 is basically 33%. So here's what we have. We have our sampling distribution here. Excuse my curve. And we know that the mean of this is 0.3. We're trying to figure out that if we have a proportion of 0.33, what is the probability of getting this or something greater? Now, if you remember back in Chapter 5, in order to find a probability like this, we used normal CDF. So we're going to use the normal CDF command in your calculator. The lower bound for this is going to be 0.33, and the upper bound is going to be infinity. Well, I don't like trying to get infinity in my calculator, so I just use a bunch of positive 9s. And then we're going to apply the mean and standard deviation that we found in our sampling distribution here. So the mean is 0.3, and the standard deviation is 0.0458. And when you put this in your calculator, you get 0.256. So we have about a 25% chance that we will get a sample proportion of 33%.